Hello, geometry students. So this is the warm-up we did on the block day this week. It'd be a good one to look over, see if you can do it yourself. If you've got some questions, ask us in class. We'll try and do a couple more like these to keep it refreshed in your brain, but you should try those out. It's just a good practice. I'm going to skip ahead into the section we actually talked about in class, though, because there's a lot of stuff you should really probably be aware of so that you're ready for the CBA, which is coming up. Let me switch this guy. Which is coming up next week on the block day. So how can we prove triangles similar? Well, first of all, similar, remember, that means that they're the same shape, but they're different sizes. So maybe I've got a little triangle here, and then I quadruple the size of it. Obviously, the sides are not congruent. They are actually proportional. Okay. And I would take notes on this somewhere. You're going to want it so that you can review when we do the actual CBA prep stuff. The angles, however, let's say I have a 30, a 60, and a 90. When I quadruple the size, the angles do not quadruple with it because, remember, they always have to add up to 180. So they're going to stay exactly the same no matter how big the shape is. As long as they're similar shapes, they'll be congruent angles. And there were three ways that we talked about that you can prove triangles similar. We had a couple little acronyms. One was side, side, side. So that means that all the sides are proportional. One was side, angle, side, which means two sides were proportional and they had one set of congruent angles. And then we had AA, which means that you found two sets of angles that are congruent. So those are our three options for proving triangles similar. I'm going to give you guys a few examples, and then there's a worksheet that you can do for practice, which we did in class. I would highly recommend you work on that to get some practice on this. You really do need to make sure you know what you're doing for this. Okay, so on this one, we're trying to prove that triangle BAC is similar to triangle QRC. That's our goal. Now think of like in English class when you write a persuasive essay, you don't just write your opinion for 5 paragraphs. You give some supporting evidence, you give reasons, you give facts and data, and then you conclude it at the end with your final thought. It's kind of the same thing here with proofs. Now there's a really nice easy one to start off with here. You see these 83-degree angles. It's kind of obvious that they're congruent to each other because they're both 83 degrees. Well, when you're proving it, you got to actually write that stuff out. I know it's obvious, but think about if you're handing this off to somebody else down the line. They may not know that the angles were already there. You need to actually write it out for them. Now, not only do I need to write out what the statement is, I got to give a reason. When something is already put in the picture for you or told to you flat out, you need to say that it is given. Okay, given means that it's already in the problem, it's given to you, and that tells the next person, hey, this was already there. It's not that I calculated anything, it just was already in the picture. Okay, now remember our acronyms that we talked about. We're shooting for either SSS, SAS, or AA. Now, I've already figured out one obvious set of angles, so I probably don't want to use SSS, okay? But I can't use SAS either because none of the sides actually have numbers on them, all right? You cannot prove sides are proportional unless you have numbers to put in a proportion. And unless you can solve with Pythagorean theorem or trig or something, that's really not an option here, okay? So I'm going to cross this guy off. That means I'm looking at angle, angle. I've already got one of the angles taken care of. So now I got to figure out where the heck this other set of angles is. Now, if you remember way back, we talked about a lot of different types of angles, but a big one some of you might remember is this one that we said it looks like a bow tie, or it looks like two lines crossing like an X. Some people learn it as two V's making a point right there. Whatever you learn it as, when you see this kind of shape, these two angles are congruent to each other because they are vertical angles. Okay, so vertical angles are always congruent. They make that shape that we've got right here that looks kind of like a bow tie. Now you do have to either mark the picture like I did or write it out kind of like up here. So I could say BCA is congruent to QCR by vertical angles. So I could either write what I'm writing off to the side here, oops, not verticals, vertical angles, or I could put it in the picture with these double arches and write the word vertical angles off to the side. Regardless, you have to include vertical angles. That's your reason why they're congruent. You have to use that. That's my second set of angles though. So now that I've got all that taken care of, I'm good to go. And my final thing, my concluding paragraph, is I'm saying that these two triangles are similar by AA. So you do have to actually state the triangles, and you do have to state that it's by AA theorem. Okay, that's our concluding thought with that. Next example we're going to do, we've got separate triangles now. They're not connected at all. Our goal at the end of it is to be able to say that DFE is similar to triangle DCB. So if you need to pause here and copy this down, that's fine. I would get this put on a separate piece of paper so you can reference it later. So checking our SSS, our SAS, and AA, let's see what kind of options we have. We're given two sides in each triangle, and we have one angle in the middle that's shown as congruent. I mean, that kind of lowers it down pretty easily. Our only option is SAS. Not necessarily our only option. We can't do SSS because the third side is not given to us and there's no way to solve for it. AA, we could use that angle, but I don't see any other way to prove that these angles are congruent to each other. There's no vertical angles, there's no parallel lines, so SAS is our option here. So let's start with the easy part. And if you can, please pause here and see what you can write down on your own. You might be able to come up with some of the information by yourself. You don't need to have me just go through the whole thing. Otherwise, I will go through it. The first obvious thing I see is that these two angles are congruent. Okay, now you don't want to put angle D is congruent to angle D. You want to use your three letters. So E, D, F is congruent to B, D, C. And because it's already in the picture, it's already shown as congruent, our reason is given. You have to put given in there. I don't care if you think it's stupid, you need to have it in there. Okay, so there's our angle. Now at the sides, you are not going to write something like this. Remember we talked about in this slide that the sides are proportional. They're not congruent. That means you have to actually make a proportion. So I have two sets of sides, so I'm going to make a proportion for those. A lot of you can probably see where the numbers match up, but to make sure, you need to use the trick we talked about when we did this unit. And that's that the smaller side, so the smaller side in this one is 26, needs to match up with the smaller side in this one, which is 10. So 10 is going to go over 26 because they're the smaller numbers. 15 is going to go over 39 because those are the bigger sides, therefore they have to go together. Okay, now you can just solve this a couple ways. You can either do cross multiplying, which works for this one, or you can divide the numbers. I'm going to do the dividing route because that's the way I prefer. If I do 10 divided by 26, I get 0.38. I'm just going to round it. And if I do 15 divided by 39, I also get 0.38. So because those numbers match up, I have proven that those sides are proportional to each other. I don't need to write out the letters or anything. I know that's kind of what we're used to from the angles, but because the sides are a proportion, that's proving that they are proportional. So we don't need to necessarily say that. If you want to, you can. You can put DF over DC is equal to DE over dB, and that shows that they are proportional. So you can do that if you need to, but this is work enough that I can see. The last thing I need to do is to actually include this SAS, so I do need to say that this is by SAS, just to finish that off. Okay, feel free to pause, go back, listen to that if you need to. These are great examples of what you're going to see for your CBA. Last example I'm going to do, this one is a little bit sparse with what they give you, kind of moving up in the critical thinking. we're trying to prove that STR is similar to VUR. That's our goal. So let's check out our options. Remember I said, unless they give you sides, you can't use sides. If I look at my picture, no numbers are there anywhere at all, which means SSS is out and SAS is out. You gotta have the sides given to you, otherwise you can't make the proportion. So I'm left with angle, angle. Okay, now hopefully the easier one to see, kind of similar to this one, looks pretty similar in shape, is those vertical angles in the middle. Okay, so I'm just gonna mark it in my picture like this because that is a way you can show that you're saying they're congruent, is with those arches. Make sure, kind of like how I did here, use single arches for one and double arches for a different set. So I'm going to start with single arches there. I still have to state my reason. My reason is that they are vertical angles. Okay, so this is enough right here to get that part proven. I have it drawn in. I have the reason here. So that's great. That's one of my angles taken care of. Now I got to take care of the other one. Now the only thing they actually give us are these little triangles. And if you remember, hopefully you do, those triangles mean that the lines are parallel. That does not mean that they are proportional or congruent in any way, shape, or form. It simply means that they are parallel. So think back to first semester when we had parallel lines and we had a transversal cutting through it. We had a lot of different angles that we found. We've got vertical angles that we've talked about already. We also talked about alternate interior, alternate exterior, corresponding. All of those types of angles come into play anytime you get two sets of parallel lines. I'm going to draw a line through TU to get my transversal in there. That was a little bit crappy there. That makes it a little bit better, I guess. Okay, but now this picture kind of looks like this one down here. Some way that you can remember this is that if you get a Z shape, you're going to have what kind of angles? Hopefully you remember. Let me draw them in here. Think about what type of angles are they. Hopefully it's kind of coming back to your brain that they are alternate interior angles. Alternate means opposite. Interior means inside. So they're between these two parallel lines, just like this one. They're between the two big parallel lines. This one's on the left-hand side. This one's on the right. So I'm going to make a little note next to it that's abbreviated, but it still stands for alternate interior angles. And again, you can write this off to the side. I could have written out these red angles as 3 letters and then wrote vertical. I could have written the blue ones off to the side using my 3-letter abbreviation and then written alternate interior underneath. Okay, or you can put it in the picture like I did. Either way, I have angle-angle theorem now. And I need to finish it off by saying angle, angle there. And now I've proven that the triangles are similar. Okay, so I would definitely get these 3 down so that you can reference them later. Now what I'd like you to do, if you were gone on the block day, you really need to do some practice on this. So please go to the attached paperwork. Yours, I don't know if it's blank or not. If it's blank, make sure you fill in the diagram. So you'll notice possibly in the one that you get that the numbers may not be filled in here. So if that's the case, then kind of go through this video and pause if you need to. I believe I put the filled in copy though. But just work on this front page, these first 4 problems, and do just like I was showing you. Show the evidence, prove by SSS, SAS, or AA that the triangles are similar. And then I also have provided the key for this worksheet as well so that you can check and see if you did it correctly. Again, we did this in class, so if you were gone, you missed a really big part of the review, especially because this is a big problem on the CBA. It's worth more points than the multiple choice. Okay, so hopefully that helps. If you need any help, email me or free to ask in class.